We're asked to solve x squared plus 4x plus 8 equals 1 for x and leave our results in the form of a complex number a plus bi. So that gives me a hint that I'm probably going to have a complex set of solutions to this quadratic equation. Let's start by putting this equation into standard form. That's going to be x squared plus 4x plus 7 equals 0. All I did was subtract 1 from each side and then subtract that 1 from the 8 and then leave 0 on the right hand side. I'm going to identify my coefficients a, b, and c. A is 1. That's the coefficient of x squared. B is 4. That's the coefficient of x. And c equals 7. Now I'm going to go to my y equals, and I'm going to go ahead and graph my quadratic in standard form. That's going to be x squared plus 4x plus 7. I'm going to press graph and just verify that indeed my parabola does not cross the horizontal axis. That gives me a visual clue that I'm going to have complex solutions to the original equation. So to solve for x in this case, I'm not going to be able to use my calculator. I'm going to have to use the quadratic formula. So I'm going to use my negative b, so that's negative 4 plus or minus b squared. So b is 4. Notice I'm putting that in parentheses even though it's positive. Minus 4 times a, which is 1, times c, which is 7. I'm going to extend my square root here. Make sure my fraction bar goes all the way underneath, and then 2 times a goes underneath. So that's 2 times 1. So be sure that you understand where all the numbers came from. Negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Let's simplify where we can. I get negative 4 plus or minus square root. 4 times 4 is 16. I have a minus sign and no other negative, so that's going to be negative 4 times 7, 28, divided by 2 times 1 is 2. If I combine underneath my square root, I get square root of 16 minus 28 is negative 12, divided by 2. Now what I'm going to do is I'm going to break up that square root in a couple of different ways. The first thing I'm going to do is remove the square root of negative 1 from the square root of negative 12. I can do that because all I'm doing is multiplying. This piece right here equals I. So I now have negative 4 plus or minus I times the square root of 12, all of that divided by 2. Remember, I is the square root of negative 1. Now, I can continue to work with this square root of 12. I cannot reduce the 4 and 2 because I need to see if I can remove some common factor from the square root of 12 first. So let me write this as negative 4 plus or minus I, and then 12 I can write as 4 times 3, so that's the square root of 4 times the square root of 3 if I'm looking at the square root of 12. All of that is divided by 2. That equals negative 4 plus or minus square root of 4 is 2. I'm going to take that 2 and move it in front of this I. Just looks a little bit better to have the number up front. Square root of 3 over 2. Now I have a common factor of 2 in this term, and in the denominator. So I can remove a 2 from each term in the top, leaving me with negative 2 plus or minus I times the square root of 3, all divided by 2. Be very careful that your fraction bar goes all the way across. Now I can reduce, there's a common factor of 2. I have left negative 2 plus or minus I times the square root of 3. However, we were asked to write our solutions in this very particular form, which is the form of a complex number. So I have two solutions. I have x equals -2 plus I times the square root of 3. And we can even say that's x1 if we want to, and x2 is -2 minus I times the square root of 3. But let's be sure and write it in this form, this a plus bi form. So a and b are real numbers. That's -2 plus, here comes b, square root of 3 times I. See how I put that in parentheses so that you can identify the b, and then the I does not sneak under that square root symbol. Let's do the same thing here. -2 plus negative square root of 3 times I. So this is our minus solution, but I put the minus here inside with the square root of 3. So that's kind of my b term here. So each of these is written in the form a plus b times I. So these are my two solutions for x right here.